So there's our exam paper. I'm just going to show you the formula that's given in the exam in the formula sheet. For the time series, the additive is the actual equals the trend plus seasonal plus random. That can also be written as y is equal to t plus s. Okay, and if we want to put in the random, we put in or, but we don't worry about that. Okay, so we're going to take this formula, y is equal to t plus s, to help us with the calculation. And we're asked to get the seasonal component here, for quarterly seasonal component. And to do that, we need to get rid of the t value on the right side of the equation. So y minus t will give us that s value that we're looking for, to help us get what we're looking for. Okay, so again, I'm going to just jump back into Excel to help me with those calculations. So here's what I recommend you do. Do not bother writing out these numbers. You're going to have plenty of time anyway to do it on the day. But if you want to write them out, if not, there's no need. Put in your headings year, quarter, put in Y instead of home loan approvals, and we're going to put in T instead of trend. Okay, so you see your formula is already set up here for us in that heading. Y minus T equals S, and that's all we have to do. So Y minus your trend. And I don't mind if you want to do this on Excel and submit the file, but most people will use pen and paper, which is perfectly fine. So I don't expect you to do this. Okay, we can't do it for that last column, y minus t. So please don't put in 8.7 in here. You have to leave it blank. Okay, so that's the first part of what we have to do to complete get the seasonal component. Okay, your next part is what we have to do is get the adjusted average seasonal component. And all that means is that we need to get, because later on we're going to forecast 2019, and we need seasonal component figures for 2019 to help us forecast what the home loan approvals might be in that year. So this seems pretty all over the place in terms of consistency, or it's inconsistent. Like, for example, quarter 3 has a negative 2.9, and the quarter 3 in 2016 has a 1.1. And if we look at all the quarter 3s, they're different numbers, but the good thing is they're negative. If we look at quarter 4s, they're also negative. This one is positive here, actually, and this one is negative. So what we need to do is we're going to get an average quarterly seasonal variation for each of those quarters, and we're going to use those then to help us forecast 2019. So all I need to do is get a figure for the quarter 3s, and I'm going to add those up and average them. I'm going to do the same for the quarter 4s. I'm going to add these up and average them. And likewise, I'm going to do for quarter 1s. You notice here, this is quarter 1. I'm going to do the same for quarter 1s and the quarter 2s. I'll add those up and average them all. So I don't mind what way you want to do it, but I just do a kind of a table. And you can follow this table if you want to. If not, just do a simple calculation, adding those up and dividing it by whatever number there are. There's about 3 of them in there. So if I put in my headings, quarter 1, 2, 3, and 4, and list all my quarter 1s, so I have 0.3 in here. My next quarter 1 is negative 2.5. And my next one is minus 0.9. I'm going to get a total. Don't mind the formula that I'm putting into Excel here. But I just need to sum those 3 up or total them up. I have a minus 3.1. Okay. So this is the average change, the average seasonal change for all of quarter 1s. Okay, so it moves by about -1. I do the same for quarter 2. Put in all my quarter 2 values. I add those up again. Okay, so they should add up to 6 if anyone wants to double check that. And I get the average of that, which we have as a 2. Okay. Likewise for quarter 3. Again, I add those up. And I get the average. Because there are three figures, I divide it by 3. And we have a negative 1.633. And I just do it again for quarter 4. You see it's starting to look like a table, but on their own, they're just addition and division. So we're adding those 3 numbers to get this total here and dividing by 3. And they just happen to be side by side to create what looks like a table. Again, getting the total, getting the average, we have these figures. So here's how I create a table. I'm just going to put in total. I'm going to state that this is the average. I'm going to say that these were quarter 1s, just in case you might think that they belong to the calculation, those numbers. Okay, set it up like that, so that should be fine. If I'm not going to bother putting the years in here. Okay, in the column you might see in some past exam papers or something that we did in class, we might have had years in here, but I just set up all the quarter 1s, 2, 3s, and 4s, and that's perfectly fine. What we need to do next is I need to total these averages up. That's what I'm going to do on this side here. You can put it anywhere you want to, but I just tend to follow this particular format. So summing these 4 figures up, I have a negative 1.233. Okay, and what I need to find here is a value that should be equal to 0. I'm looking for a 0 here. The reason why I'm looking for a 0 is if you recall like a regression line that we have, or even if you recall the diagram that we did where we plotted these 2 sets of numbers, and that value of white had a tendency to move around the trend line. What we're trying to do is balance out the seasonal variation or the seasonal effect where you had a positive where t was above y or where t was below y. And what we're trying to do is trying to balance all of this out. And if you balance it all, you should end up with a total of 0. Okay, so for example, here we don't have it. There's nothing wrong with this figure, but what we're going to do is just tidy up the data and make this equal to 0. And how to make it equal to 0 is just put in the positive sign of what we had above here. They'll add to 0. Okay, so what I'm going to do is just make an adjustment. I'd advise you to just go to 2 decimal places on all of these figures, by the way. In the exam, there's no point playing around with 3 or 4 decimals. Okay, it's just going to be a lot easier for you. Okay, so this might be a little different because I made an adjustment, but just let's assume that this is correct, a negative 1.23. I need to make an adjustment of 1.23 and spread it across each of these. So does anyone have any suggestions how I might allocate the 1.23 across the 4 quarters? I wouldn't make an adjustment on one of them. For example, I would not put in a 1.23 here. What will happen is when I make the adjustment, I'll turn that negative into a positive. So a negative 1.03 plus 1.23 will make it a 0.2. So I don't want to do that. I want to, whatever is negative, I should keep negative. And whatever is positive, I should keep positive. So in this case, what I might do is you could perhaps divide this across by 4 and equally distribute the answer across the 4 here. Okay, but I just think it might be easier to pick a high number, for example here, and adjust that by maybe 0.5, which means I have another 0.73 to work with. I might adjust this one by also 0.5, and I might make an adjustment of 0.2 and 0.03. So all of those added together will give me the 1.23 I need. And this is called adjustment, because that's what effectively I'm doing. I'm making a change or an adjustment to the average. And my next heading is called the adjusted seasonal average. In other words, I'm just going to add the average and the adjustment figure together. So so everyone's going to have different answers here because you're all going to be using whatever adjustments. So you're adding these 2 together, you're adding these 2, and these 2 to give you the resulting answers that I've highlighted in blue. So that's your answer for part 1.